This video is an explanation of exploratory factor analysis, EFA, definitely more commonplace in communication research than its counterpart. Unlike confirmatory factor analysis, CFA, which tests the factors already identified by exploratory testing, exploratory factor analysis attempts to identify highly intercorrelated groups of variables as means of data reduction. For example, respondents to a survey might answer 24 questions relating to the behavioral motivations for adoption of a new technology. Factor analysis looks for linear combinations of variables that can be used to construct an index or scale for those motivations. The idea is to reduce 24 items into 2 or 3 or 4 related factors. Thus, factor analysis is an advanced multivariate process that creates vectors for groups of variables. Each score in the vector is an element, and the number of elements in the vector is the vector's dimension. The degree to which each element is correlated with other elements in the same factor is called a factor loading, very similar to a correlation. Although you can survive factor analysis without fully understanding the underlying linear algebra, you might want to know that the total squared loadings are called eigenvalues. Because EFA identifies new variables, these vectors are comprised of weighted combinations of variables called centroids. Because principal components analysis, PCA, separates vectors, PCA is most often used with EFA. You need 200 to 300 cases to get much out of exploratory factor analysis. Once you have the responses for a dozen or more items, which are often subtle variations on a similar theme, you can use SPSS to extract the factors. My best explanation to the uninitiated is to imagine the values tossed into a mathematical cloud where various solutions are rotated inside the computer until an ideal pattern emerges. Lots of math going on, but all you do is press the extraction button and follow the standard recipe for minimum factor loadings and eigenvalues, maybe studying a scree plot to determine how many components or factors result from your PCA process. Most communication researchers uses the Varimax rotation, so why shouldn't you, for example? If you remember that factor analysis does two things, you should survive this video. You get to develop more sophisticated measures, and you can reduce the number of independent variables. Years ago, my frequent collaborator and I was so eager to study something brand new that I forgot to construct our dependent variable, which was new media adoption, intended or real. It's hard to test a research question about a relationship or differences without a measurement of the outcome, just the inputs. But I managed to salvage the project by turning it into an exploratory factor analysis that revealed new combinations of predictors, that is, new measures for the next study to apply to some dependent variable. Here's what we did. We asked 70 questions. I'll show you the questions we asked. You don't need to look at them too closely, but there were 70 different questions, and we asked them of 128 respondents, of which we only had 114 usable responses. So we already fell short of the recommended 200 participants. But I think the results are interesting, even if I forgot to measure adoption. So what you do is you choose Analyze, then Dimension Reduction, then Factor. Then you dump all 18 of the motivations into the variables box. I've already done that. So there are 18 different variables representing the motivations for radio station managers to adopt a new technology like HD radio. Then go to the descriptives link and choose univariate descriptives. I think initial solutions already checked. Choose coefficients and KMO, then click on continue. By the way, the selection variable is left blank for this. Next, under the extraction menu, choose correlation matrix if it isn't chosen already. Make sure the eigenvalue is greater than 1. You will be given an unrotated factor solution. You can leave that. Choose the scree plot. It helps a little bit. And make sure that the maximum iterations for convergence is 25. Then under rotation, as I mentioned earlier, why not use Varimax? Everybody else does. Click Continue. Under Scores, make sure the Display Factor Score Coefficient matrix is checked. And then under Options, make sure that in addition to being sorted by size, you also suppress the small coefficients. Anything below 0.50 you really don't want to see when you're looking at your new factors. Click on Continue, and then click on OK. Lots of output, some of which may not be immediately pertinent, but you have your factor analysis done. Head directly to the percentage of variance explained. That would be total variance explained box. And you'll see that it's almost 74%, most of which came from the first 3 unnamed factors. Looking now at the scree plot, the level seems to occur after the 5th factor, confirming the power of the underlying math, because you were just told you had 5 factors. Ignoring the unrotated matrix, go down to the rotated matrix. This particular box shows you that it took the computer 5 times to optimize this particular solution. The really fun part of exploratory factor analysis, indeed the only fun part, is naming the factors. Here's what we chose for ours. The first 5 items seemed concerned with the image of the radio station. The next 4 were about programming. The next 4 were about other stations in a radio market, competition. Then there were a couple of concerns for revenue and cost, which may seem the same, but the exploratory factor analysis saw as different dimensions. Had we been able to see how well the factors worked, we might have regressed adoption on the 5 factors, but we lacked the means, again, because we forgot to ask about the real or intended adoption. Don't make that mistake in your own research. Always think about the kinds of tests you expect to run before you collect all the data. As it turned out, we made lemonades from lemons. See you next time.